Okay, so in this video, okay, we're going to look at center masses of some simple laminas. Okay, mostly ones that have lines of symmetry in them. Okay, so when it comes to shapes with lines of symmetry, okay, your center of mass, okay, will lie somewhere on that line of symmetry. Okay, so if the shape only has one line of symmetry, then you know it's going to be in the middle of it. Okay, if it's got two lines of symmetry, then you know it must be in the center. Okay, where those two lines meet. Okay, so that's really, really important to consider. Okay, so when we've got, like, for example, a rectangle, we know it's going to be in the middle of a rectangle. When we've got a circle or an oval or something like that, okay, we know it's going to be in the center of that. Okay, triangles can be a little bit hard to deal with. Okay, so we'll look at how we can deal with those in a couple of different manners. Okay, and we can go from there. So those are the key points for this one. Now let's look at this example. Okay, so again, I've drawn it already. Okay, but we'll talk about how I've thought about how I'm going to draw it and things like that. Okay, so I've got a uniform lamina. Okay, it takes the shape of a square, which is A, B, C, D. So I'm going to call my corners a square A, B, C, D, like so. Okay, which all have a length of 8a. So again, this length here, let's put a length in a different color. That length there would be 8a. Okay, and so are the rest of them. I'm just going to label that one. And has a center of O. So the center is going to be about here. That's my center O. Point E is a distance of 2a from O, where OE is parallel to AB. So if OE and AB are parallel, E must be somewhere over here. Okay, it doesn't matter which side it's on. A second lamina consists of a disc of radius A stuck onto the lamina with the center of this being E. So the center of my disc here is at E. That's point E. Okay, and then I know this got a radius of A. Now, it did also tell me the distance O to E was A, so that means this distance here must also be A. Okay, now, a few extra bits for us to consider before we go on to it. We've got it stuck on. Okay, so that means when I think about these central masses, I'm not taking things away, I'm adding them. Okay, if I had a shape cut out of it, I would take masses and things like that away. Okay, so be careful of what we're dealing with depending on the shapes. Okay, now it does then tell me the surface density of the disc is 3 times the surface density of the square. Okay, so because of this, I'm gonna go, okay, let's the surface density equal sigma. Okay, because then from there I can go, okay, that means 1 sigma and 1's 3 sigma. Okay, now I need to find the center of mass from the origin. So I want it from the origin by here. So that's why I'm going to set my axes. There's my y direction. There's my x direction. Okay, now there is a line of symmetry here. Okay, and the line of symmetry is straight in the x direction. Okay, now this is where it gets confusing. Let's remember, on the x-axis, y is 0. So on this x-axis here, y is 0. So that means my y bar must be 0. Okay, and that's because of symmetry. Let's just remember that all the x bar and y bar are their points. Okay, so if it's symmetrical in the x direction, okay, so on the x-axis, y bar is 0. If it's symmetrical in the y-axis, then x bar would be 0. So be careful of what one you want to be. Okay, which means I only need to look at the x component of this. Okay, so I've got to split it up. I'm going to have to do it for the square. So I've drawn my table. I'm going to do the square, and I'm going to do the disc. Okay, and I'm going to do the full shape, which I'm going to have to add together. Okay, because I've stuck them on, so full is added. Okay, now I'm going to work this using the idea that I talked about last time, in that the fact that my moments for my center of mass would equal the sum of the moments for the other things. Okay, so first of all, let's do their masses. This could be my mass column. Okay, so the mass for the square is going to be, using density, okay, is going to be my area okay, times my surface density. Okay, so in this case, my area is going to be 8a squared, and I'm going to times that. Hold on. Okay, I should have fixed that now, so it should be working. Okay, I've got 8a squared times by the surface density, which is sigma. Okay, which I'm going to tidy up. Okay, is going to be 64 a squared sigma. Okay, and now let's do the same mass for a disk. Now I've got the area of the disk, which is going to be pi r squared, so a squared times by pi, and then times by its density. Now remember, it's three times. Sorry, that keeps happening. So it's 3 times. So it's 3 sigma. So I end up with 3a squared and then pi sigma. Okay. Now let's remember, I now need to do the full mass, which would be those two things added together. So I've got 64 a squared sigma plus 3a squared pi sigma. Okay, now I'm just going to simplify this a little bit because I've got some things I can factorize out here. Okay, I'm going to take out the 3a squared sigma, leaves me with 2 pi, sorry, 64, not 2 pi, let me ignore that. I'm not going to take out the 3. Okay, we'll just get rid of that, shall we? There we go, that's better. There you go, fixed it. So I got 64. So I'm taking out the a squared sigma, leaves me with 64 plus 3 pi. Inside my bracket, there we go. Okay, so that's my final mass. Okay, now the other thing I'm going to consider, okay, is where their x bars are for each one. Okay, now I don't know what the x bar is for this, and that's the point. Okay, so let's go through each one. So for the square, let's think about where the center of mass is going to be in the x direction. Well, it's going to be in the middle. So it's going to be its origin. So it's going to be 0 away. Okay, now let's think of where the center of mass is this circle is going to be. Now it would be, okay, we're back, I think. Yeah, we're back. Right, so the center of mass for E would be at the center. For the circle, would be at the center of the circle. Okay, now I've got to think about where that is in compared to O over here. Okay, now remember, that is 2A away. So my x bar in this direction is going to be 2A. Okay, and there's that everything done. Now, normally we draw that extra bar, that extra column, don't we? Where I've got the sum of mx. Okay, and if you're comfortable using that method, that's completely fine. Okay, but what I want you to start to consider, okay, is maybe this other way of thinking about it. It may help later down the line with some other things. Okay, so what we're going to do is I'm going to do moments. Okay, I'm going to do it about the origin. Okay, now my moments should be the fact that the moments for this full shape should equal the total moments from the other one. Okay, now that's if I'm adding and subtracting, depending on what we're doing. Okay, so my moments for this first one is simply going to be its mass times its displacement. So I've got a squared sigma, then 64 plus 3 pi, and then times by x bar. And that should equal the total moments of this one, okay, which is going to be 64 a squared sigma times 0 plus, because I'm adding these two things together, 3a squared pi sigma times by 2a. Okay, let's tidy it up a little bit. Okay, I've got a squared sigma 64 plus 3 pi x bar. Okay, this is going to be 0, so it's going to disappear. This one, let's simplify. I'm going to end up with 6a cubed pi sigma. Okay, and let's see if I can simplify that any further. Okay, so straight away, I need to get x bar on its own. So the first thing I'm going to do is I'm going to okay, apologies for that. It should be working now. So I'm going to do, let's go back to it. I was doing a squared sigma 64 plus 3 pi times x bar. That's my moments for the whole shape, and then this should equal the moments for the other shape, other shapes combined. So 64 a squared sigma times 0 plus 3a squared pi sigma times 2a. Okay, and let's tidy it up. So a squared sigma is 64 plus 3 pi x bar. That's going to be 0, so I end up with 6a cubed pi sigma. Okay, and let's simplify this out a little bit. Okay, so a squared can go from here, and I can get rid of the cubed. The sigmas can go. Okay, I need x bar on its own. So my x bar is going to be 6a pi all over 64 plus 3 pi. Now in this case, I've got a letter involved. I've got a, so I can leave it as that. Okay, I'm actually going to write it as 6 pi over 64 plus 3 pi a like this, okay, just so I have a coefficient. Okay, now I could technically type down my calculator. It's not going to give me a nice number, so I'm going to leave it as that. Okay, so I'm just going to write, therefore, center of mass. Okay, it's going to be, well, this is this x coordinate, so 6 pi 64 plus 3 pi a, and then its y component from the beginning was 0 by symmetry. So there is my center of mass for this shape. Okay, so that's taking moments. Okay, that's the idea, that we take moments, and that your total moments. So when we take moments, okay, my moments for lamina should equal the total moments of each shape. Okay, now so that's a thing to consider for these kind of questions. Okay, and this can work as well for other shapes as well. Okay, when we deal with triangles and things like that. Okay, so what we're going to do is finish it on this video. Okay, we've got one more question to do in this booklet. Okay, and then we'll probably make some extra videos as well on the exam questions. Okay, but apart from that, I'll see you in the next video.